So, Christina, do you want to introduce yourself first?
I'm Christina. Christina Copy. I am lead PM in the messaging team. You may know of me, if you do know of me, from the app service team, where I used to work on a variety of networking things.
Thank you. Yeah, I'm Held Groteboer. I'm the project manager for Azure Service Bus. And so today we are going to show you a bit about Service Bus and Event Hubs, our innovation for today and tomorrow. So what can you expect today? We will be sharing about a quick overview of what is Azure Service Bus and what is Azure Event Hubs, the differentiation between those two services. So we get a lot of questions around this from our customers. When should I be using which service? How do they compare to each other? So we're going to talk about that. We are going to run over our recent releases. We are going to give you a bit of insights in our upcoming features and a bit of an insight in our roadmap. So let's start with a quick overview. So before we start into the service themselves, we first have to understand what there's quite different kind of messages. So this is why we have these different services. So we have, of course, Event Grid there as well, which we won't talk about today, but it's definitely also one of our very important services. But when we look at messages, we can basically distinguish in these kind of messages and many more. I won't go through all of them, but just call out a few of these. For example, a command: I want you to do something for me. I'm expecting you to do something. I don't know who's going to do this, but there's someone out there that's going to do something for me. Or a request: get me some data, do this, get me some of information. On the other side, we also have, for example, notifications, which tell more about, hey, something has happened. And so if we set these aside, then basically we can distinguish between intents, where I want something to happen, I'm expecting something to do something for me, versus information, which is more about, this is what happened, and someone might be interested in this, but it's not part of my specific workloads. And this basically difference between messaging and eventing. And eventing we see as a subtype of messaging. And this is already a very important distinction, because messaging is really about the intent to do something for me. Eventing is really about the information. Now, if you look a bit deeper into events, we can also distinguish two types of events here. So first of all, we have discrete events. So discrete events are basically independent of each other. So they stand on their own. They report a state change. So, for example, a blob was uploaded, an invoice was created. So it's some kind of state that has changed. And they are actionable. So when something happened, I might want to do something. And so, for example, a blob was uploaded. When a blob was uploaded, I might want to resize an image that was uploaded. Or I might want to start an OCR run. If an invoice was uploaded, I might want to then send out an email to someone. But so these are really discrete events. They're on their own. They are not part of a larger stream, which is the other type of event that we have. So a stream is time-ordered events. So they're part of a larger stream. So they all come together and they are ordered in time. They are petitioned on a certain context. So there might, for example, be they are petitioned on a device ID. They might be petitioned on an order ID. But there's some kind of context that they are petitioned on. They report a condition. This is my current state. So, for example, the current temperature is X, or my car is at this location now. So they report a condition. And you can analyze these events in a stream. So over time, you can see what happened to your data. So you might be able to see, how did temperature change over time? Where is my car that's driving around? So those are different kind of messages and events that we have. And that's really important to understand why we have these different services. So I will talk a bit about what are the different services. And like I said, today we are going to focus on Service Bus and Event Hubs. Event Grid will have their own sessions, so definitely also watch those if you want to know more about Event Grid. But let's start with Azure Service Bus to explain a bit about what is this service. So what's Azure Service Bus? Azure Service Bus is basically like a post office. You have a producer, something that communicates data, that wants to communicate data between different software systems. And then within the post office, within Service Bus, you can receive those messages, route them, and publish them. The systems don't need to know about each other. So the consumer doesn't actually have to know about the producer. They don't ever have to meet, because they have this post office, or in our case, Service Bus, in between. And you can now easily add, remove, or change parts of the system without disrupting your whole environment. So if any part of your system needs to be changed, you only have to change that one connection instead of having, which you might see with the spaghetti architecture, as we call it, where everything is connected to each other. When you have to change one system, all the chain systems are exchanging data with the system has to be changed. Once you put something like Service Bus in the middle, you can basically do this without any disruptions. So Service Bus is really about enterprise messaging as a service. So first of all, it's about that messaging, about those intents. So Service Bus is a platform as a service. So we host this for you. You just write your scenarios and your application in there. It has queues and topics. And so queue is basically you put something into a queue as a producer. You have a consumer that picks the message out of the queue. Each message goes to one consumer. The consumer then processes the message and either completes it when it's successful, or it might abandon it or delete it if something happened. A message will be processed once. At least if you complete the message, it will be processed once. If you cannot complete it, then you should put it back on the queue. The next consumer will pick it up and will then consume it. But in theory, it will be processed exactly once. It allows for reliable asynchronous communication. So Service Bus, Event Hubs, we are really about reliability. We provide 4 nines of on our SLA. And we really, what is most important for us is that we guarantee you that you'll never lose a message. You can use things like message headers to set up routing. So if you can set message headers, you can use those to actually route your messages to different destinations where you're using topics or subscriptions. And actually, I now realize that I may have mentioned queues, but not topics. So topic is actually similar to a queue, where you put something into a topic, and then you can have one or multiple subscriptions. And so those subscriptions each have one or multiple subscribers again, and then each subscriber once again gets a message from their subscription. So together with those message headers, you can route messages to specific subscriptions. A message might go to all the subscriptions or only to specific ones. So basically that allows you to do that routing and filtering. And like I said, at least once, at most once, and exactly once. So depending on what kind of log mode that you use. So we have a receive and delete log mode, where basically you have it will be received by a consumer. If something happens to the message, the consumer is in control of it. So that's at most once delivery. We also have at least once delivery, where you use our peak log mode. And that's the one where basically you pick the message up and you can either abandon it or complete it. You can also do exactly once. It has a bit more effort, but you can use something on your consumer side where you can also keep track, what did I already process, and then basically restart in your process where the process might have stopped. It has a rich feature set, and I'm not going to run through all of these, but just to give you an idea of what are all the features that we provide. Here's a complete list. It's too long, like we only have 40 minutes today, and we want to take your questions as well, so I won't go through all of these. But I want you to show you that Service Bus is really about that rich enterprise messaging feature set. So we basically allow you to do anything that you might need to make sure that your messages are come across with the right intent to the right places without you having to worry about this. So I do want to highlight a couple of the features of the Service Bus Premium tier. So we have 3 different tiers. We have Basic, which is basically only queues. We most often see this for maybe simple task queues or very easy test workloads. We have the Standard tier, where you can go with your lighter workloads. It's pay as you go, so you only pay for the message that you send through. And we have the Premium tier, where you pay per hour, and which has a lot of premium features that you might want to have for your really enterprise scenarios. So for example, you run on dedicated resource with Premium, so you actually get your own resources. We do this in the form of a messaging unit. And so messaging unit gives you some dedicated resources that are just for you. We guarantee that when you want those to use the resources, they are available to you. We also have GeoDR there. At the moment, it's just metadata GeoDR, so we replicate your queues and your topics and things like that. We are going to talk a bit more about GeoDR in a later slide, but for now, that's what we have. We also have large message support, so message up to 100 megabytes you can do in Premium. JMS 2.0 compatibility, so if you are using something like IBM MQ, typical EMS, you can very easily switch to Service Bus. We have availability zones in there, so basically availability zones allow you to have your namespace running in 3 different instances in 3 different data centers. We always have 3 instances, by the way, so we always have 3 instances. In non-availability zones regions, this will be 3 instances in the same data center. When you are using availability zones, they actually are in 3 different data centers in the same zone. So even if a complete data center goes down, we can very immediately switch over to a different data center, and you can just keep running without any impact. VNet integration, of course, where you can actually insert your service bus into a VNet and use it only from your own network. Partitioning is something that we recently released 2 weeks ago at Ignite, where you can actually have multiple partitions in Service Bus Premium, and each partition gets 1 to 16 mesh units of throughput, which basically means that you can now scale to any workload that you want. So that's Service Bus, and I hope that you now understand what this is used for. It's really about the messaging, enterprise messaging scenario. Like I said, today we're also going to talk about Event Hubs, and Event Hubs is really about streaming data. So if you look at Event Hubs, basically it looks a lot like a tape recorder. So basically it records a stream of data, so you have a lot of data that comes in, and that data comes in a stream, so one bar after another. So the recording, the incoming messages only move forward. So you can not say, I want to append something in the middle of the stream or something like that. Messages are always placed at the end of this stream. Now you can, of course, go back and forward over that stream. So similar to that tape deck once again. So if you have a stream of data, Event Hubs uses a client-side cursor, and its client-side cursor, as the name suggests, is controlled by the client. So the client can actually say, I want to read the data from the stream from this specific point in time. So you can actually go back in this time, you can go forward in time, and just play the data over from where you want. And for example, if you are using something like event sourcing, you might say, I want to replay that order from a specific point because I might have lost some data in my backend or something else. And this way you can easily go back in time and replay that. So you can replay this from anywhere. And then you can, like I said, go back and forth for this. You have multiple channels, what we call partitions. So you have multiple partitions and your data are spread across the partitions. And let's actually talk a bit more about those partitions because they are a very big part of our architecture. So when we look at the Event Hubs, basically we have those partitions in Event Hubs, and those partitions are where your data will land. Now, you can have many event producers, and those producers are going to send data to your partitions. You can do this using Kafka protocol, HTTP, or MQP. And so those producers are going to generate data. The data will land in one of the partitions. You can be in control of this on which partition something lands by setting a partition key. Or if you don't care about the exact order of this data, you can also do this without partition key, which gives you a bit more of throughput. On the other side, we have our event receivers. So the receivers that are interested in playing back these events. So you can have up to the total number of partitions that you have. So let's say you have four partitions, then you can have 1, 2, 3, or 4 consumers. Those receivers are going to listen on a consumer group, and basically a consumer group is their abstraction between those partitions and the receivers. And so those consumers are then going to listen to those partitions, and each consumer will start listening on one or multiple partitions. If we want to bring in other receivers, we can also create a second consumer group. And in this case, similar, so we have another consumer group with listens there, but the data, they are in control over themselves. Like I said, with the client-side cursor, each of these receivers has their own client-side cursor. So each of these receivers can go back in their own stream of data. The stream of data will just stay there, and they can go back in time in that stream. So for those of you that already know Kafka, you might be thinking this is a lot what Kafka is doing as well, because they both use that partition consumer. They both have those partitions that are independent of each other. They both use the client-side cursor concept. Both can scale to very high workloads. And conceptually, they are indeed the same. So that's actually why we decided to have the Event Hubs for Apache Kafka connector. So you can actually use your existing Kafka applications, connect them to Event Hubs without changing any code. You can just connect them and it will work. So we have an endpoint that's fully compatible with Kafka. Like I said, you just change your connection string and it will work. So you can use any of your existing Kafka applications, but also the tooling that comes with Kafka. And you can use this with Event Hubs. So it has all the features that we are going to discuss more of these, but so it has all the features that you would expect from Kafka. So things like log compaction, Kafka compaction, Kafka Connect, Mirror Maker to support, JSON schema support, and schema registry. Now, another thing that we have that is really awesome, if I can say so, is EventOps Capture. So EventOps Capture allows you to batch your data stream. And what does this mean? It basically means that you can upload your that stream of data that's coming in. You can upload that onto storage and then use that storage for your big data workloads. So it's based on a policy. So basically you said, I want to upload it every X minutes or every X megabytes. So for example, you can say either when I hit 5 minutes or when I hit 25 megabytes, for example, I want to create an Afro file on my storage with all that data. So you can use this kept data then as a source for your big data processing pipeline. And what's really cool about this is just a checkbox that you set. So, and imagine that we are talking about big streams that are coming in, a lot of data. And what we saw is that if our customers, when they were building themselves before we had this feature, they had a lot of performance impacts. So we decided to build this for you, so you don't have to worry about this. We give this to you in a very easy way, so that you can have both your fast stream and your slow stream, both from EventOps, without you having to think about how you do this. Another service that we have is Stream Analytics. It's not a message broker itself, but it's very closely related to EventOps. So as we are processing this very big stream of data, we need something that can handle that stream, that can handle that massive amounts of data, and that can easily bring this to where we need to go. So this is where Stream Analytics comes in. So Stream Analytics allows for real-time event stream processing. So basically, on your EventOps, you can connect your Stream Analytics, and it will start reading that stream. So it can process large volumes of streaming data. That's really what it's about, like that big pipeline of data that coming in with that big stream, that you can process this very, very easily. It has sub-millisecond latencies, so it goes really fast. And it has a nice intuitive graphical drag and drop tool that is actually built into EventOps. So actually you can go to EventOps, say that you want to process the data. It will show you a no-code, low-code experience where you can drag and drop. You set your input, you set your outputs. For example, send my data to Power BI, send my data to another EventOps, send my data to Service Bus. So it's very easy to set this up and very easy to quickly get started with processing your fast data. So something that we also recently released at Ignite was Microsoft Fabric Event Streams. So event streams are event streaming offered as a SaaS. So instead of PaaS, so EventOps, Service Bus, Stream Analytics, these are PaaS services. Microsoft Fabric is actually a SaaS product that we also have event streams in. So it allows you to capture, transform, route in real time your events to various destinations with no-code experience. And this is actually powered by EventOps and Stream Analytics under the hood. So when you create one of those Microsoft Fabric event streams, we are actually creating EventOps and Stream Analytics for you and giving you all that those capabilities that we have here for you to very easily get started. So differentiation. Like I said, we get a lot of questions from our customers. I want to do some messaging or eventing. Which service do I need? I talked about what is EventOps now, what is Service Bus. So let's have a look at what are differentiations. So when would you use queues? You would use queues if you need a first in, first out approach. So FIFO approach. So you put something in that goes into the queue and it will be in order in the queue, guaranteed order. And so your consumers pick up every time the first message that was in the queue. It allows you to do competing consumers pattern. So you have multiple consumers. And those different consumers will all compete for those messages, as we say. So basically what it means is that every consumer gets one message and they process that message. And the other consumer gets next message, the other consumer gets next message. And so that way you can have multiple consumers that are processing these messages in parallel. Guaranteed at least once or guaranteed only once. And so what it looks like is kind of like this. So we have our producers on one side. We have the queue in the middle. We have our consumers on the other side. Those producers are going to produce messages, so going to place messages on the queue, and our consumers are going to ask for the first available message. So the first message gets picked up by one consumer, the second message gets picked up by the second consumer. And of course, we can now continue this as we go with many more messages as well. Also very important here is that once a message has been acknowledged by the queue, so if your producer sends a message to the queue, gets back an acknowledgement, we will never lose that message. That message will stay there until you get it from that queue. So topics and subscriptions, the other part of Service Bus. So topics and subscriptions you would use if you want to do with multiple consumers. So we have a producer that only knows about the topic side. So producer sends something to a topic, and you have consumers that only know about their specific subscriptions. So under subscriptions, you can have filters and actions. So filter allows you to say, I only want to receive this specific subset of messages. An action you can use to actually update your metadata, the message headers, and that way you can also chain things together. So what does this look like? Once again, we have producers, we have consumers. In this case, we have a topic. On the topic, we might have a filter. So in this case, we have 3 subscriptions. So the first subscription has a filter of type equals order. The second subscription has a filter of type equals quote. And the third subscription has a filter of type equals order or quote. Now, as we are starting to send messages, so we have one producer that's going to send order messages, one producer that's going to send quote messages. And so the order message will end up in both subscription A and subscription C. And the quote messages will end up in both subscriptions B and subscription C. So this is where you would use queues and topics. Where would you use streams? Streams if you want to do that real-time data streaming. So if you have a large suite of real-time data that you want to process. Like I said, it supports Apache Kafka workloads, so you can easily move those over as well. And it's really about high volume throughput with very low latency. And so it basically is like a fire hose. So you have consumers that want to have like that stream of data. You have event hubs, and you have a producer that is going to create that big stream of data, big stream of messages, big stream of events. So stream processing, of course, as well. Like I said, often when you want to have that stream of data, you want to process that data in an easy way. So that's where Event Hubs plus Azure Stream Analytics comes in to do real-time event stream processing. So it allows you to process large volumes of the data very easily with sub-millisecond latencies and use that no-code drag and drop editor that's built into Event Hubs. And so basically this looks very much, of course, like Event Hubs. So it's Event Hubs plus Stream Analytics. And so you once again get that big stream of data in. Stream Analytics is going to process the data. It's going to do your analysis over this. And it's going to push this to your consumers. So if we look at Azure Mesh Platform, like I said, so Azure Service Bus is really about connecting apps on an enterprise messaging, queuing, and PubSub platform using open protocols, so including JMS 2.0. Azure Event Grid, which we'll hear more about later in this conference, is about publishing and subscribing to MQTT messages and HTTP push and pull for delivery of discrete events. So Service Bus is about messaging, Event Grid, discrete eventing, and Event Hubs is about cloud scale low latency streaming platform supporting Apache Kafka and AMQP client services, so streaming events. And of course, Stream Analytics to make it really easy to process the events in Event Hubs. So the real-time stream processing and the analytics engine with rich development tools and low-code, no-code editor experience. Now, 75% of our S500 customers use 2 or more of these mesh brokers. And that's important to understand. So this is what this was about, or this is about the differentiation. These are 3 different kind of scenarios that you want to implement with this. Don't be afraid to say, I'm going to spin up both a Service Bus and an Event Grid, or a Service Bus and Event Hubs, or even all 3 of them. Pick the ones that you need. Look at your scenario, pick what fits your scenario. Also, open protocols are really important for us. We are very much involved within these protocols to make sure that we adhere to them. We even help they design some of these. So we have support for cloud events on Azure Event Grid. We have support for MQP on Service Bus and Event Hubs. We have support for MQTT on Event Grid. We have support for Kafka on Event Hubs. And we have support for JMS on Service Bus. So there was already a lot of information about what is Event Hubs and what is Service Bus. So I hope you have a better understanding now when would you use which. Now the second part of this session, we want to talk about what are we building? What have we built? What are we building? So basically, I want to give you some insights into what is the things that we think that you might need, and please give us feedback on this. Like, give us feedback what we release if you like this, what you might want to see improved. On what we are building, let us know the scenarios this is going to solve for you. For us, it's really important to get your feedback because in the end, we are building this for you. So we want to make sure that what we are building is what you want. So first of all, passwordless authentication for JMS. So we already have password authentication on our Service Bus API for quite some time, where you can use managed identity or service principal and use that to connect to your Service Bus. However, about 6 months ago, I think, Ability also released password authentication for JMS. So if you are using JMS with Service Bus, you can now also use your managed identities and service principals there. Of course, this is all backed by Enter ID for authentication. And as you can see here, it's really easy to get to connect your application to that managed identity, get your token, and use that to authenticate with us. So we also have two performance features. So the first one is consistent low latency entities on your entities. And we are basically doing this by moving to a new storage provider. We used to run all our storage on Azure Storage. However, sometimes what we would get is we had a minor network glitch, storage might have a minor blip, but once you are talking about 40 or 50 milliseconds P99 latency, anything that hits you will immediately be a big hit. So we are now actually moving to a multi-tier storage, where we first go to our local storage on Service Fabric, and then offload on Azure Storage as needed. By this, we greatly improve our reliability because we are no longer dependent on Azure Storage, on the network, or anything like that. We just go directly to our own local storage. And also, we are bringing down our latency from 40 to 50 milliseconds P99 to about 35 milliseconds P99. The second performance feature that so by the way, consistent low latency entities is currently public preview. You don't have to do anything for this. You automatically get onboarded on this. And actually, let me go back one step. This is part of a much larger investment that we are doing on our underlying platform. So we are moving from cloud services to VMSSS. And so as we are onboarding all our customers on VMSSS, you automatically get this feature. It's on the premium tier. And so on the premium tier, you automatically get this feature as we are moving you to this new infrastructure. Everyone will be moved to this new infrastructure by next year. And so at some point, we are already in the process of migrating you. So if you see a nice drop in your latency, this is what has happened. The second feature that we have released, and this is actually now in GA, is partition namespaces for premium. So on the premium tier, you can also create partition namespaces. We already had partition namespaces on standard, although they work quite a bit different. On standard, where you say that your namespace is partitioned, we automatically create 16 partitions for you, and your messages are spread across those. For premium, however, you specify how many partitions that you want. And with those partitions, you can now scale higher than you could do previously. So up until now, you could basically scale from 1 to 16 message units. And on each message unit, you can get about 2,000 to 4,000 messages per second or 2 to 4 megabytes per second, depending on which features you are using, how your workload is actually looking. But let's say that's about the baseline that you can get. Now, because we had a limit of 16 message units, that would mean that at some point, maybe about 60,000 messages per second, something like that, you would start hitting that limit. You could not scale any further. And so we had customers coming to us. We want to scale 100,000 messages per second, 150,000 messages per second. How can we do this? So we introduced this new feature where you can now create partitions on your premium namespaces. And each partition gets 1 to 6 message units. So let's say that you create a namespace with 4 partitions. That means that you can now scale from 4 to 64 message units. Is even not enough for you? This is not the hard limit. We have currently chosen this limit because we don't see our customers that need more. But this is not a hard limit. We can increase this limit even if you want to. So please, if you have a higher limit than 4 partitions, reach out to us and we can help you with this. Do note that this is really for high throughput scenarios where absolute order and message distribution is less important. Because we are now using partitions, messages basically go to a random partition. So similar to event hubs, as I explained, the messages go to a random partition unless you specify a partition key, or if you use sessions, which basically allows you to process the messages with the same session ID, by the same consumer. So, of course, you can still do this. So messages can definitely go to the same partition if they need to be able to stay together. However, it does give you a small impact on the performance. And like I said, this feature is really about the highest performance. So if you don't need it, don't enable it, but you can if you do need it. So the relative order is still preserved. So messages in the same partition are still in order. And like I said, you can use partition keys or sessions to enforce that order. Christina, do you want to talk about this part?
Sure. I'll jump in on compaction. So we recently released log compaction for event hubs. This allows you to retain the latest version, latest copy of a message with the same key. This is useful for taking up less space, ensuring you're using the last record, and a number of other things. It was also required for some other features we were building. This is available for our standard premium dedicated tiers. It's not in basic, but you should use basic anyhow. Rather have you in standard. Yes, come to us. And then let's see, what else could I say about that? That's fine. Next item.
Yep. Kafka Connect.
Kafka Connect. So we added the ability for you to use Kafka Connect to basically take advantage of the vast pool of connectors that are available. This interacts cleanly with event hubs. You don't have to do anything different than you would with a normal Kafka deployment. And it works nicely also with the Event Hub schema registry, as it's pointed out.
Yes. Mirror Maker.
Mirror Maker 2. I don't know if you guys have ever used Mirror Maker 1. Show of hands, who's used Mirror Maker 1? Yeah, live performances are better in person. But Mirror Maker 1 was nowhere near as good as Mirror Maker 2. Mirror Maker 2 supports far greater traffic loads, and we were happy to be able to announce support earlier this year. This will allow you to basically seamlessly connect to Kafka clusters. So if you wanted to wire up your on-prem Kafka system and have it feed your Event Hubs cluster, boom, Mirror Maker 2. If you wanted to move from, we'll just say, another service that runs Kafka and move your data over to Event Hubs, this is the way to go. And it's great for migration purposes as well as just normal runtime. Supports offset replication. It supports basically replication however you want to go about it, whether it's migration or runtime. Fire away. Next one. JSON schema support. So this capability is in preview. Previously, we just had Avro support, which is pretty similar, but we had Avro support in the schema registry, and right now we've got JSON schema in preview. Please try it out. If you have any feedback, let us know. This lets you easily share your schema between your producers and consumers, making your overall experience far cleaner. Yeah, right? Mirror Maker 2 is great, isn't it? Well, Mirror Maker 2. Mirror Maker 1, I like Mirror Maker 2. You may have picked up an undertone of passion. So, next one, what do we got?
There we go.
Data generator for Event Hub. So I love this feature. It's still in preview, and I'll tell you why later when we talk about what's upcoming. But the data generator for Event Hubs lets you actually send in sample data to your Event Hub. You no longer have to code up an application just to test drive data into your system. So if you wanted to learn, do a demo, just exercise your system to see how it works end to end. The data generator is a really slick tool. Event Service Bus has had the edge for a while with their own Explorer and data generator experience. And so, now we have Event Hubs catching up a bit. Next one. Manage identity for capture. So this is a big deal. So we used to have capture, as Elder went into. Capture is a fantastic feature. And the small gap was you didn't have the ability to use managed identities with it. Now, as we all know, doing the managed identity intro auth stuff is just a far more secure method than just using a simple password, SAS key, etc. So this adds security to your overall system. You avoid the problem of wandering SAS keys, and it basically also lets you pass compliance audits.
Yes.
Great feature. I love this.
Yes.
Coming
So
soon.
next part, yes. So next part is what is coming soon. And when we say coming soon, this is basically what we hope to release in the first half of next year. Of course, this is all under the disclaimer that this is in development. Things might not go as we were expecting initially, but this is basically what we want to have released in the first half of next year. Now, I do know we only have 5 minutes left, so we will go to this quick, but we just have way too much things that we are releasing. So, but first of all, geodata replication. So this is something that we're actually building both for Service Bus and Event Hubs. Both of them are currently in private preview. So the new geodata replication, like I said, we already support geodata replication in Service Bus, for example, for the metadata, but not for the messages in there. So with the new geodata replication, we are going to do full data replication across multiple regions. You will create a namespace. You'll say where your primary is, where your secondaries are. You can use synchronous and asynchronous replication, where synchronous replication basically means you send something to the client, to the service. We commit it on the primary. We sync it to the secondary. We wait for the answer on the secondary. Once committed to a quorum of secondaries, then we send back the acknowledgement. RPO 0, no data will ever be lost. Of course, some added latency. Asynchronous replication, on the other hand, you send it to the primary, we commit it on the primary, we give back the acknowledgement, so same as today, and then we start replicating your data. So synchronous replication is your RPO 0. Asynchronous replication, you will set your RPO. You are in control of this, so you can set, for example, say my RPO is 10 minutes, and we will make sure that once you hit that 10-minute replication lag, then we start throttling incoming requests, so you will never lose more data than you are allowed to. You will be doing a manual failover, but we'll give you telemetry to automate this. You are in control of that failover. You will know when you want to failover normally. You also might want to fail over other parts of your application. So we give you the telemetry so that you can automate this, but you will be in control of this. And like I said, releasing for both Event Hubs and Service Bus. On Service Bus, we also have durable terminus. So durable terminus basically allows you to survive connection breaks. So as we are going more toward containers, distributed systems, instead of having nicely in one data center, things are now spread all over. And so what happens at that moment is that your connection might break for some reasons. It might be because a container got restarted, a network hiccup, we are doing maintenance on your cluster, but for whatever reason, your connection might break. And at that moment, you also link breaks between your client and the service. Now, when the link breaks at this moment, you lose your mesh state, and mesh becomes available again on the queue. The next consumer picks it up, and the message might be processed twice. So what we are going to do instead with durable terminus is introduce a new lock mode. Currently, it's called durable lock. Might still change depending on feedback in the private preview. But with that new lock mode, you basically can say, I want to keep a lock on this message, and don't release the lock until I say it to. So even if your connection breaks, you will just reconnect. If you are using our SDKs, it will all happen automatically for you. You will just reconnect saying, hey, I'm back again. Please give me back my message state. And this way, you can have one consumer that is completely locked into that one message. So no more messages that are being posted twice because of connection breaks. No more need for renewal of locks. It's just yours. Delayed abandon. So basically allowing you to place a message at the back of an empty with a delay. So you don't need send permissions, you only need to receive permissions, and reschedule message will be placed at the back of the empty. And I do see that we are almost at time, so I will start going a bit quicker to those. These are smaller features, so we can go a bit quicker to those. If you have any specific questions about any of these, by the way, please let us know in the questions, and we will happily answer those. Batch delete, allowing you to delete messages in batches, up to 4,000 messages per batch. So it will be improved performance over receive and delete. You no longer have to receive message. We will actually do this server side. Peak message by state, being able to say I only want to see the message in an active state or in a scheduled state. And this basically allows you to do better scaling with functions and with KIDA. Christina, can you
Kafka transactions. So we've got two gaps within our Kafka support. One is lack of support for Kafka transactions. We're working on that. Next one, I'm going to go light speed here. Kafka Streams, bingo. So we're working on both of those. Next one. Data Explorer. This is the one that I was the connection back with the data generator. So we're going to put them out together so you can generate data and see your data, which is like fantastic. Just like what you could do with Service Bus, we'll be adding that to Event Hubs. Next. Large message, you can have big messages. Next. Protobuf supported in schema registries. So we've got Jason and Avro. We'll be adding Protobuf. So that's cool. Rounds out essential need. Roadmap. We're at time. Nobody gets to know what the roadmap is. Yeah, there's only 2 quick items.
Yes. So first of all,
just for information, Clemens and Kevin are on the chat and answering questions like crazy. So the most of the questions that they had for you, it was a lot of them, they already answered. So feel free to get those last 5 minutes for questions to go through roadmap and stuff.
Yeah.
Perfect. Then we can talk a bit about the local emulator. And I can actually hear people cheering outside right now. So the local emulator, the thing that everyone has been asking for, we are building it. So yes, we are building this both for Event Hubs and Service Bus. So Event Hubs, hopefully beginning of next year, Service Bus probably end of next year. Of course, this is actually roadmap stuff. This is definitely not a guarantee. It will be there at that moment. Let me make that very clear. But just give you at least some indication of what we are hoping for. It will be a containerized version of the of Service Bus and Event Hubs. You can run it cross-platform. It will work on Linux. It will run in a container, so you can run this on your local machine. You can run this in your test pipelines, and it will have all the functionality that makes sense for a dev test environment. Now, for example, for Service Bus, what that means is, yes, you'll definitely get queues and topics. No, you will definitely not get GeoDR. Then there's a whole slew of features in between, and we are going to figure out what are the features that make sense for a dev test scenario, and what are features that would make sense to actually just keep on the surface. Please let us know what you need here. If you have specific scenarios, let us know them so we can see, okay, what are we going to include. And like I said, releasing for both Event Hubs and Service Bus, with Event Hubs coming first and Service Bus coming next. Subscription metrics. So another ask that we get a lot is that our customers want to know our customers want to know what happens in their subscriptions. So for our topics can have up to 2,000 subscriptions. So let's say that you have 16 machine units. Each machine unit can have 1,000 topics. Each topic can have 2,000 subscriptions. There's a lot of metrics that are being generated there. And so at the moment we cannot push this to our MDM system because they will start falling over. So we are now going to first push our subscription metrics into Log Analytics. Later on, so this will be very much out on the roadmap. At some point, we'll have premium metrics that we can hook into. But for now, we are going to do this with Log Analytics. We'll push those metrics into your Log Analytics from your subscriptions. And you can then use Kusto, etc. to create alerts, create dashboards, and things like that. And with that, we're almost done. So quick takeaways. Of course, identify the scenario that you're working on. Make sure you're using the right service. Make sure that you're using the right features. If you have any questions around this, there's a lot of help, of course, from our community, but also from us. If you feel like something is missing, let us know. Use those services in conjunction with each other. Our services complement each other. You don't have to choose one. You can actually use multiple. Like I said, you can have a stream of data coming into Event Hubs. Have your stream analytics, process that stream, and then send specific messages to Service Bus for actually start taking actions. So they actually work very nicely together. So also make sure that you take care of that capability. And once again, provide your feedback. There's Azure IDs that's out there. There's GitHub. There's other places. Please provide us your feedback. Azure IDs is actually, or Azure feedback. I don't know what to call it these days. I think it's Azure IDs. Use that because that's most important, where you can actually upvote other people's initiatives, or you can put in your own. I look at that every week to see what you are requesting from us. And we actually use this every time that we are planning our backlog. We use this to make sure that what we are planning is actually what is being asked for. So with that, thank you. And let's see if Wagner has any questions remaining for us.
There was a question on can they look to search on a